Okay, here we go, starting a new chapter. This is chapter 2, Inequalities. All right, section 2.1 is graphing and writing inequalities. So first, what is an inequality? So an inequality is basically a statement that two quantities are not equal. Not equal is the most important part there. Basically, an inequality is a comparison of two quantities. All right, pause here, get that written down. So the quantities are compared by using one of the following signs. So remember the alligator mouth, where the alligator mouth opens to the bigger one. So this guy right here, we read it from left to right, like we read everything in English. And this is A is less than B. Then similarly, we have this guy like this, where the alligator mouth is pointing at the A. And again, we compare our numbers from left to right. So we write A is greater than A is greater than B. Then we have this guy right here, which is kind of like this one. This one says A is less than or equal to B. So less than or equal to. And then similarly, we have the opposite direction, which means that A is greater than or equal to B. So less than or equal to, greater than or equal to. And then lastly, we have A is not equal to B. So the little line through the equal sign just means not equal. Which just means that A and B are not the same. All right, so if you notice, every single time we start with the one on the left, and then we write our sign according to that. All right, pause here to get this copied down. All right, so we can actually solve inequalities, and the solution of an inequality is any value of the variable that makes the inequality true. All right, so pause right there to get that copied down. So what does this mean? If I have x less than 9, that means the solution of x is all numbers. I don't know what part of that got recorded or not. So what I was saying was x less than 9 means that x can be any number that is less than 9, or all the numbers that are less than 9. So x can be 3, x can be 4, x can be negative 27. X cannot be 10 because that's more than 9. Remember, we want everything less than 9, and since we don't have a little equal sign on the bottom, it doesn't include the 9. So just less than 9, not including 9. So that means it goes all the way up to like 8.99999 forever, but not quite 9. All right, so for example, say we have 3 plus x is less than 9. And they want us to describe what the possible values of x are in words. Well, let's try some values of x. So let's see, for x equal to 1, we get 3 plus 1 less than 9. 3 plus 1 is going to be 4. 4 is less than 9, so that works. All right, what if we did x equal to 8? Then we have 3 plus 8 less than 9. 3 plus 8 is 11, less than 9. 11 is not less than 9. So no, can't be 8. So if we look here, 3 plus x less than 9. So let's think of any other numbers that could make this true. So let's see, what about x equal to 5? 3 plus 5 less than 9. That's going to be 8 less than 9. All right, so 5 works. What if we went up to 6? So we have 3 plus 6 less than 9. 3 plus 6 is going to be 9. Is 9 less than 9? No, right? So basically, up until we got to 6, we were okay. Anything over 6 is not going to be true. Like if we tried 7, 3 plus 7 is going to be 10. 10 less than 9? No, sir. So everything up to 6 works. So how would we write that in words? We would write that the solution of 3x, 3 plus x, less than 9 are numbers, less than 6. In other words, we can write x less than 6. All right, now since this is just too many numbers to list, how we show this would be to graph it. So we would have a number line like this. Here's our number 6, 7, 8, and then 5, 4, blah, blah, blah. So we would be at 6. We would have an open circle because it does not include 6. And then we want all x's less than 6. So, for example, 5, 4. Since these are the ones that make it true, on this side of the, what is the word I'm looking for? This side of the 6, we draw our arrow that way. So that is how we graph that. And we'll go into detail about what the circles mean in just 1 second. All right, so let's talk more on how we graph these inequalities. So as we said, we can have something like this, x less than 5. So we would draw our little number line. We would draw the number 5. And then you could draw some to the left, some to the right. So we want all x's that are less than 5. So here's 5. Now notice how it says less than only. and not less than or equal to. So because of that, we're going to put an empty circle there. That empty circle means it does not include 5. And then we're going to draw our arrow this way to show all the numbers that are less than 5 are a solution to this right here. Let's do another one. Say we have x greater than -1. So once again, we draw our number line. We draw -1. I'm going to draw some numbers to the left. I'm going to draw some numbers to the right, just for funsies. All right, so -1 is our key term here. That's this guy right there. It does not include -1, so we're going to have an open circle. Think of this being a little bag, and since we don't have -1 in the bag, it does not include -1, our bag is empty. And we want all the values that are bigger than -1. Well, we're going to look at our number line, and everything that's bigger than -1 is going to be on this side. So we draw our arrow in that direction. So that's how we would graph the solution set for that. All right, so that's in the cases where our answer does not include that number. So when we have just greater than or just less than. But remember, there's also greater than or equal to or less than or equal to. So say we had x less than or equal to 1/2. So we draw our little line. 1/2 is our important key term there. And then we'll draw some numbers to the right and some to the left. So let's see, left of 1/2, we would have 0, and then -1/2, and then this way we would have 1, and then 1 and 1/2, and whatever. All right, so 1/2 is the number we're looking at. Now it's less than or equal to. So equal to means it includes that 1/2. So our little bag is now full because it includes 1/2. So we're going to color it in. And we want all the numbers that are less than 1/2. So which way are the numbers that are less than? Is it these? No. Is it these? Yep. So that's the way that we draw our arrow. And that's how we graph that solution set. And let's say, hang on guys. Sorry, I had to take a COVID cough break. All right, so we have x greater than or equal to 0. So once again, we draw our number line. 0 is our main term here. We'll draw some numbers to the right. 1 and 2. We'll draw some numbers to the left. -1 and -2. All right, so we have greater than or equal to. Greater than or equal to. Does that mean that the 0 is included or not? Yes, it is included because we have that or equal to. So does that mean our little bag is empty or full? It's full because the 0's in it. We include the 0. So let's go ahead and draw a colored in dot. All right, and we want all values of x that are bigger than, greater than 0, greater than or equal to 0. So these numbers are smaller than 0, so that's not quite what we want. We want the ones that are bigger, which are going to be the ones on the right. So we're going to draw our little arrow to the right like that. And that's how we graph our solution sets. So to recap, open circle we use for less than or greater than. Closed circle we use for less than or equal to, greater than or equal to. So when we include the number, it goes in our little bag, so it's full, so we color it in. If we don't include the number, then our bag is empty, so it's an empty circle. Make sense? All right, so let's do a couple more examples of graphing. So for example, let's graph b less than -1.5. So what number are we going to start with? -1.5. And I'm going to write some numbers to the left and some to the right. You really don't have to, but I do it anyway. So let's see. To the left of negative 1.5, we'll have negative 2, negative 2.5. To the right, we'll have negative 1, negative 0.5. All right, so we want all b's that are less than negative 1.5. So does that include the negative 1.5 or not? It does not. So does that mean I have an open? Sorry about that, guys. So we have all numbers less than. It does not include the negative 1.5. So is that an open circle or a full circle? It is an open circle, right? Because our little bag is empty. It doesn't include the 1.5. Negative 1.5 is not in there. All right, and we want all the numbers that are less than negative 1.5. So less than negative 1.5 are going to be all these numbers to the left. So we're going to draw our arrow that way. And that is the graph of our solution. All right, let's do another one. So we're going to do r greater than or equal to 2. Draw our number line. Once again, what is our key number to start with? 2. Draw some numbers to the right. So 3, 4, some to the left, 1, 0. Let's draw an arrow here so we don't forget who we're talking about. All right, so it says r greater than or equal to 2. Does that include the 2? Yes, it's got that little line on the bottom that means or equal to, so it includes the 2. So does that mean we're going to have an open circle or a filled in circle? A filled in circle, right? Our little bag is full because the number 2 is in it. All right, and we want all the numbers that are bigger than, so greater than 2, which is going to be all the ones on the right. So we're going to draw our arrow like this. And that is the graph of our solution set. All right, pause here if you want to copy that down. All right, so we talked about graphing the inequality when they give us the inequality, but what about if they give us the graph and they want us to write the inequality? So let's see what happens then. So for example, say we are given this number line right here. We have, an open circle on 4.5, 5, 5.5. This way we have 4, 3.5, and the arrow goes this way. All right, so first thing we're going to do is we're going to write our variable on the left. And then we're going to write that key number where that open bag is, or our circle. And that's going to be 4.5. So first things first, are we going to have a line on the bottom or not? Meaning, are we going to have something like this or like this? No, because it does not include the 4.5. So it's just greater than or less than. All right, now we got to figure out which one it is. So x is all these numbers over here on this side to the right. So x is 5, 5.5, whatever. So x is greater than 4.5 is our answer. All right, so next let's do our number line. We have a solid dot at -3, -4, -5, -2, -1. All right, and this time the arrow is pointing to the left. So we're going to write down our variable. We're going to write down our key number, which is -3, where that circle's at. All right, so that is a filled in circle. So does that mean we're going to have a line on the bottom or not? Yes, we are, because we want to include the 3. So let's go ahead and draw our little line. So basically, we're looking for greater than or equal to or less than or equal to. Now, which way is that arrow pointing? We're pointing to the left, and all the numbers on the left are going to be less than -3. So we're going to write x less than -3. And that is our answer for that. All right, let's just do a couple more of these. So let's draw our little line. Open circle at 7, 8, 9, 6, 5, and the arrow's pointing to the right. So as always, we're going to write our x, and we're going to write our key number, which is where that circle is at. So it's at the 7. Now, are we going to have a line on the bottom or not? No, we're not, because it doesn't include the 7. It's an open circle. So we're going to have either less than or greater than. All right. Now, the arrow is pointing to the right. And to the right are all the numbers that are bigger than 7. All the numbers greater than 7. So we're going to write x greater than 7. All right, last example, and I think we should be good on this. So let's say we have solid circle, -1, -2, -3, 0, 1. And it's pointing that way. All right, so we write our variable, we write our key number. We have a solid circle, so that means it includes the -1, so that means we're going to have a little line on the bottom, the or equal to line. Our arrow is pointing to the left. To the left are all the numbers that are less than -1. So we write less than. And that is our answer. All right, how do we feel about that? Let's move on to a word problem, and then we'll do our in-class problems together. So it says the members of a lightweight crew team can weigh no more than 165 pounds each. To find a variable and write an inequality for the acceptable weights of the team members. Graph the solutions. All right, so let's change the color so we know we're working on our solution. So the team members can weigh no more than 165. All right, so let's call the team members weight. We'll call them W. Our key number is 165. All right, let's draw out a number line first so we can visualize. So 165, 170, 175. This way we got 160, 155, etc. So 165 is our key number. We want no more than 65. So what can it be? Can it be 170? No, because that's more than 65. We want no more than. So 65 is the max it could be. It could be 155, it could be 160, doesn't matter. But the max it could be is 165. So does that mean it includes or does not include the 165? It includes the 165. The 165 is the most it can be. So we're going to draw a solid circle. And we want all the ones that are no more than, meaning smaller than 165. So our arrow goes this way. So how would we write that? Well, we write the little line on the bottom because we have a filled in circle. And we want all the W's that are less than 165. So that is how we would write our inequality, and that is how we would graph it. All right, also to note, can we have a person who has a negative weight, like a negative, can someone weigh negative 3 pounds? No. So we actually have to cut this off over here at 0. We're going to do an open circle at 0 because a person can't weigh 0 pounds, usually. I don't know. Maybe in another universe. Maybe a ghost. But a live human person cannot weigh 0 pounds. So everything up until 0 pounds, although I doubt there's going to be anyone weighing 1 pound. But hey, it's a possibility, I suppose. So we're going to stop our weight at 0 because it has to be a positive number. All right, and that is that. Let's get ready for our classwork exercises, which will be in a separate video.